this video we are going to just talk about story problems. So the problem that you see in your notes, it says that Fred bought 12 sandwiches for him and his friends. He spent $49.80. If a turkey sandwich costs $3.85 each and beef sandwiches cost $4.25 each, all the prices include tax, how many turkey sandwiches and how many beef sandwiches did he buy? And so the first thing that we're going to do is we're going to define our variables. And so we've talked before about how important that is, because if you don't define your variables, then your system doesn't mean anything. So first we're going to define our variables. So let's let x equal the number of turkey sandwiches. Now, of course, you can use any variable you want here. I'm just going to stick with x and y. Y is going to equal the number of beef sandwiches. Now, you can't just say turkey sandwiches. You need to say the number of turkey sandwiches, because there's other things about turkey sandwiches, like their price and so on. So since we're trying to find the number of sandwiches, that's what we're going to write. The second thing we're going to do is we're going to write our system. And so our system, we need to think about, what do we know? We know that we have 12 sandwiches total. So if I take the number of turkey sandwiches plus the number of beef sandwiches, I have 12 sandwiches. Then I know something about the prices. I know that $49.80 was the total, $3.85 each for a turkey and $4.25 each for a beef. So I can put that together into 3.85x plus 4.25y equals 49.80, and that's my system. Now I'm going to solve this system of equations, and we're going to do this 3 different ways, because we've learned how to do 3 different methods in this entire packet that you've been working on. So the first way that we're going to do today is we're going to use the inverses of matrices. So I'm going to write a matrix equation, and so I will do that with the coefficients. As we do this, you're going to find that some methods are less efficient. Some will take you more time, and you might think, why would I ever do that? It depends on the problem. Sometimes there will be some problems that a certain method would be really good for and other ones would not, and that's okay. Right now we're just learning how to do all of them. Okay, so if you remember with our using inverses, the first thing we need to do then is find the inverse. And so we're going to take this matrix right here, and we're going to find the inverse of that. So I'm going to write up here 1 over, and I'm going to do 1 times 425 minus 3.85 times 1. And when I do that math, I'm going to have 1 over 0.4, which if I do that math, it's equal to 2.5. That's going to be a little bit easier for me to work with. So it's going to be 2.5, and then I'm going to multiply that by my mixed up matrix, as I like to call it. So where you have the 1 and the 4.25 right there, we're going to switch that. And we're going to have the 1 over here be negative and the 3.85 be negative as well. And that's going to be our inverse when I multiply that all together. Now when I do the actual math, what I'm going to get is 10.625 and negative 2.5 and negative 9.625 and 2.5. And so all I did was multiply that 2.5 times over there. That's what I did. And so I'm going to take this inverse and put it in here as well. So 10.625 negative 2.5, negative 9.625, and 2.5. A little squished right there. Alright, now I'm going to do my multiplication. So remember that when I multiply these two, if I've done everything right, which I'm going to check at the end to make sure because I don't want to mess that up, I'm going to get at the identity matrix, and then I'll have my x and y right there. Okay, and then over here on the right, I'm going to multiply this row by my column, and so I'm going to write this out a little bit better. So 10.625 times 12 plus negative 2.5 times 49.80. And then I'm going to do this row times that column, so negative 9.625 times 12 plus 2.5 times 4980. Okay, now I'm going to simplify that. So I'm going to have my xy is equal to, when I simplify all of that, I get 3 and 9. Now what that means, it means x equals 3 and y equals 9. Now because this is a story problem, I'm not going to write this as an ordered pair. Instead what I'm going to do is I'm going to write my answer in context of the problem. So I'm going to say he bought 3 turkey sandwiches and he bought 9 beef sandwiches. And so that's what I just found out from solving, and I'm going to write it in context, and so that's what you're going to do. Okay, we're going to now take the same problem and now we're going to solve it a different way. We're going to use row operations this time. So the first thing we're going to do is write our augmented matrix. Okay. Alright, now remember when we did this, we are looking for this number to be a 0 and this number to be a 0. Those are my first goals. So I need to do something so that I'm going to try to get that top number to be 0. So looking at these two right there, if this was going to be a negative 4.25, that would do what I needed it to do. So I'm going to multiply negative 4.25 times row 1. I'm going to add it to row 2. And I'm going to put my answer in row 1 because that's where I want my 0. So when I go to do that, I'm going to have 1 times negative 4.25 for this problem right there. And then I'm going to add that to 3.85. When I do that, I'm going to get negative 0.4. And then, of course, these numbers right there, that's going to give me my 0. And then 12 times negative 4.25 plus 49.8, that one is going to give me negative 1.2. And then the second row is not going to change. Okay, now I can see that I would like to simplify this first row. So if I take my first row and I divide it by negative 0.4, I'm going to get 1, 0, and then this turns out to be a 3. The second row is not changing. Probably should have left more room. Okay, so now I'm going to concentrate on getting this number right there to be a 0. So I'm thinking I want to look at these two numbers, and if that top number was negative 3.85, that would work. So I'm going to take negative 3.85 and I'm going to multiply by row 1. I'm going to add it to row 2, and I'm going to put my answer in row 2 because that's where I want my 0. So my row 1 will stay the same. My row 2, I'm going to take 1 times negative 3.85, and I'm going to add those two together, so I'll get 0. Then 0 times negative 3.85, that's going to be 0, and I add it to 4.25, and I still get 4.25. And then 3 times negative 3.85, and then add it to 4980, and I'm going to get 38.25. So this is looking pretty good. So what I'm going to do next is I am going to reduce this second row, and I'm going to do that by taking my row 2 and divide it by 4.25. So when I do that, I'm going to get the top row is going to remain the same. 0 divided by anything is 0. 4.25 divided by 4.25 is 1, so I see my identity matrix taking shape right there. And then 38.25 divided by 4.25, when I do the math on my calculator there, I'm going to get 9. That means x equals 3 and y equals 9. So here again, in context, it means that he bought 3 turkey sandwiches and 9 beef sandwiches. Whoops. And so that's our answer. Okay, last one, we're going to use Cramer's rule to do the same thing. So first I'm going to take my regular matrix and I'm going to find the determinant of it. So that's going to be 4.25 minus 3.85, and that is 0.4. Then I'm going to take my matrix and I'm going to leave the y's in place, but since I'm going to find the x's, I'm going to replace the x's with 12 and 49.8 and find the determinant. So when I do that, I'm going to have 51 subtract 49.8, and that's going to give me 1.2. X is equal to 1.2 divided by 0.4, which is 3. And that goes along with the other ways that I solved this as well. Then for the last one, I'm going to take my matrix and I'm going to put those x's back in there. But this time, instead of the y's, I'm going to replace those with my 12 and my 49.8. And then find the determinant of that. So I'm going to have 49.8 subtract, and then 3.85 times 12 is 36. Oh, excuse me. I'm looking at the wrong line. 46.2, and that gives us 3.6. So y is equal to 3.6 divided by 0.4, which is 9. And here again, that tells me that I have 3 turkey sandwiches and 9 beef sandwiches.